Hey everyone, my name's Stephanie. I'm a research analyst at Messari and I focus on chain infrastructure. The last few months I've been diving really deep into the modular blockchain landscape, which is effectively a way to split up the core functions of a blockchain for optimized use cases. I recently wrote like a 61-minute report that's available on Messari.io, so if you want to know all of the different technical components and really all parts of the stack, you can take a look at that. And this talk is going to be an attempt at fitting that into 10 minutes and just giving you a high-level overview of what are modular blockchains and why we want to build this way, and some of the core things to think about when building and investing in these systems. So we have 60 plus projects that are already building modular. I just want to point out that these projects are specifically focused on the Ethereum and Celestia ecosystems, as the ecosystems are the largest developer traction and development at this point in time. But there are other ecosystems that will be the subject of future reports likely in the future. And before I kind of dig into what are the different functional components, I'll talk about why we even want to build these systems in a different way in the first place. So the first problem is slower innovation. When you're building with a traditional general purpose L1 and you want to make any changes to the core protocol, you have to be very careful in doing so. There's often one core team who's responsible for all the different functions of the blockchain, and they have to get buy-in from the larger community, and they have to just make sure that if you make a change over here, it's not going to affect something over there, and it's not making problems for the apps built on top, and it has to be backwards compatible. So that's the first problem, and largely the biggest one is that when you divide the functions, you can optimize and you can innovate faster and implement things like account abstraction, which we know that for Ethereum has taken a very long time. The second is the noisy neighbor problem. So when at times of high network demand and you have a bunch of different applications and users fighting for block space, the cost of transacting is just going to go up, and that's, as we saw in the 2021 bull market, it was nearly impossible to transact on Ethereum, and you want to think about how we can bring in more users and not have such high fees. Third problem is lack of developer flexibility at the app layer. So when you're building a smart contract application, you're often constrained to the virtual machine or the programming language of that blockchain. So when you build in the modular context, you can really do whatever and think outside of the box. So now we're going to dive into a really high-level overview of how a modular blockchain works. There's a lot of different ways to do this, but I'm going to go with the most traditional way, which is a roll-up. It's effectively considered the most secure way of building a modular blockchain. And what it is you have effectively a blockchain running on top of another blockchain, but the blockchain on top is purely focused on execution logic. So an app developer can say, what am I going to build? Am I going to build like a simple payment processing network? Am I going to build like a traditional virtual machine like with Optimism and Arbitrum with a slightly modified version of the EVM to have a similar transacting experience to Ethereum? Or you can kind of build outside of the box entirely and bring something like an LLM on chain. When you break out execution, you have to find a way to then put it back together. So you have additional layers, the first of which is the sequencing layer. And this is a set of nodes, or just one node, as we have today in early versions, that accept and order transactions from users. It's often a misconception that a sequencer is the same as a validator, but it's not, and we'll talk about that in a panel later on shared sequencing networks, I think in the next hour, so if you want to stick around for that, we'll talk to the founders of some of the shared sequencing networks. But they're a simpler version of a validator in that they only accept and order transactions, but don't come to consensus on their order and validity, and that's abstracted to the consensus and DA layer. There's also the proof verification layer, and that's the layer that effectively determines, is what happened on the execution layer in fact valid? Do we agree that the transactions that occurred there are not fraudulent? And finally, you have the consensus and DA layer, which all of you know Ethereum already, which acts as the consensus and DA layer to rollouts built on top. The nodes of that chain, which are effectively validators, they come to the consensus on the order and validity. And there's also optimized networks like something like Celestia or Avail that are going to remove execution entirely, as Ethereum already focuses on execution. So even though it does consensus and DA for the rollups, there's additional considerations there. So we're going to have optimized networks at that layer of the stack as well. There's a lot more we could go into the technical details, but again, you can take a look at the report if you want to learn more. We're going to jump into value accrual, because when you split up a blockchain in this way, you kind of blow apart the idea of the fat protocol thesis, where all of like the fees and MEV trickle down to the validators of the base layer. That still occurs, but there's also additional considerations and specialized providers that are going to jump in and also take some of that value as well. So we believe that the largest value is going to accrue to the composability enabling infrastructure of modular blockchains. And what I mean by that is there's the shared sequencer networks as well as the shared consensus and DA layers. So we talked about sequencers a bit before, and a sequencer accepts and orders transactions from a rollup, but it can also accept and order transactions from multiple rollups simultaneously. And right now there's a lot of development here with Astria, Espresso, and others that are developing networks that are permissionless, that operators can join and do so for a bunch of rollups that opt in. And what they enable is also, like they get us very close to atomic composability, and so you're able to have transactions between rollups happen within one block under certain circumstances, and so that's going to be the closest we can get to atomic composability for rollups. And we believe it'll be very important for rollups to want to have the best composability with other rollups, and that will attract different rollups to a shared sequencer to be able to benefit from that together. And then the sequencer is able to both extract inter-rollup and intra-rollup and inter-rollup MEV from officiating these cross-rollup transactions. The second and arguably the most valuable layer of the modular blockchain stack is going to be the consensus and DA layer. And that is, even though a consensus and DA layer isn't actually officiating or executing any cross-chain transactions, it's only with the shared consensus and DA layer that it will be possible to build trust-minimized composability on top of that. So we believe that there's going to be, so starting with Ethereum, which is already the most popular consensus and DA layer, considering that it's the only one that's live at the moment, out of the ones that we're going to talk about today. So that's with that, and then a Celestia and as well as a Veil, we believe there's going to be kind of ecosystems of rollups built on top of it, and the value is going to trickle down as it would with traditional validators to the consensus and DA layer, as well as being able to extract that MEV in addition to that as well. Finally, challenges. So obviously there's a lot of things to consider with this. We've never built these kind of systems before, and I think that a lot of people are afraid of building in the modular context just because it is so new and there are a lot of open questions, and so these challenges are likely going to change in the next couple of years, so just keep that in mind, but these are the ones that we think of are the most important at the time being. So the first is complexity. More layers, more problems. As an app developer, why do I want to think about all of these different layers? I just want to focus on my execution logic. And we really do believe that over time, as these systems mature, that will be the case. There are frameworks and rollups as a service providers to help make building rollups easier for developers. So rollups as a service specifically, it's like a traditional SaaS model where a rollup developer can come and say, okay, I want to build this application, and all they really know is that they're selecting from an interface, and in a few clicks they have a rollup that does the function that they want to have. Also frameworks, that's a little bit more customization, but you're able to just take an existing framework, something like the OP stack or Arbitrum Nitro, and say, okay, I want to tweak this a little bit, but now I have a fully functional rollup pretty quickly. Security. So a rollup is only as strong as its weakest layer, and this is certainly a concern, but there's also the ability for a rollup developer to choose from a bunch of specialized providers and make the trade-off between cost and security that they're comfortable with. In addition, the teams that are focusing on each layer are specialized and optimized for that function, so they're not thinking about all of the other layers and the security guarantees that would otherwise they'd have to think about if they were building a full blockchain. And I think the most important problem to think about is fragmentation. Kind of noted it before, you're never going to have full atomic composability in a rollup ecosystem. It's just not fundamentally possible at this time. So, you're going to have to think about asynchronous systems. There's always going to be at least a 2-block delay between rollup transactions, and as well as just not being able to fully guarantee that a transaction is going to be included from one rollup to the next in a cross-rollup transaction. And this is a really, really new part of the stack, but something to watch out for are intent-based architectures and order flow abstraction networks like Flashbot Suave, Essential, and others. And they're going to be building these kind of systems that connect all different rollups where the user isn't necessarily aware of what rollup they're transacting on, just that the execution path to get there will be achieved for them without them having to know the details. So that's going to be something that's coming up in the next couple years. Will be really interesting to watch. Finally, demand. who wants to build all of these roll-ups? Like, why not just build a smart contract application? And the truth is, we don't really know what the answer to that is yet. There will be certainly a killer use case that makes sense for a roll-up, but that is yet unclear. And as with any kind of emerging technology, most of these projects will fail. Like, we just got to be honest with that. But at the same time, what I think to be the most valuable thing about building in the modular context is that when you leave the constraints of building within a smart contract application or the constraints of building a full-on app chain and having to think about the validators, you can really build whatever. And so, as is the meme, I'm really excited to see what people come up with and what applications we'll see in the next coming years when you have a lot less constraints than we currently have. Thank you.